Okay, so on to how to prove a shape is a square. So we gotta kind of tap into knowing what makes a square a square. So you know that a square has all sides are congruent, all right? But that's kind of the definition of a rhombus. So what turns it into a square is also for there to be a right angle. Now, really, if there's one right angle, there's four right angles, but you only need to show one. So just like we did previously with rhombus, you're going to do all four distances. All right. Again, I recommend not pairing them by opposite sides, but just kind of hitting all four. Pick a side and work your way around. So I got the distance of AB, distance of BC, CD, and AD. I'm going to do all four of the distance formula calculations. So the square root of the change in x squared plus the change in y squared. And I compare coordinates, change in x, change in y. Remember, we're going to keep these positive because we're going to be squaring them anyhow, like the number line distances. And and in this case, it's the square root of 4 squared plus 3 squared. But then in this one, it's 3 squared plus 4 squared. And it kind of toggles back and forth. Either way, all these work out to be the square root of 25, which of course you know is 5. More importantly, they all work out to be the same. So we have our therefore that concludes that side AB is congruent to side BC is congruent to side DE, which is congruent to side AD. All right, I want to state that all four of them are congruent to each other. All right, again, that's all I needed to say. It was a rhombus, but that's not what this question is. I want square, so I have to show a right angle. So I pick any two adjacent sides, any two sides that are next to each other. In this case, I picked AB and BC. So here's AB, eye test says positive slope. Here's BC, eye test says negative slope. All right, I calculate the slopes, change in y over change in x. I get a slope of 3 over 4, and then here I get a slope of 4 over negative 3. All right, and those are important numbers. You should remember that if you have slopes that are reciprocals but opposite signs, all right, aka negative reciprocals, that concludes, here it is, perpendicularity. So you put your little therefore in there with your little mini conclusion here that says AB is perpendicular to BC, which then take it one step further. You know perpendicular lines of course form right angles. So you can then conclude specifically if AB and BC were the two that we identified, that angle B here would be our right angle. So angle B is a right angle. Again, for the 800th time, the since statement here wraps up pretty much your entire strategy. Since all sides are congruent, that's what I had here, and angle B is a right angle, that's what I got here, all right, ABCD is a square. All right, so that's how you would prove that a quadrilateral is a square. All right, hope that made sense. Geometrons for life.